Alright, Warden's back again with 9.2 geometric series. This is another type of series. You talked about geometric sequences, I think, in pre-calc. We're going to get into some now series. So series in this form that we have n from 0 to infinity of a times r to the n. And so if you have something times something to a power, you're basically saying, hey, it's a, right, times, this is really r to the 0, this is r to the 1, r to the 2, and so on. And that's a geometric series with the ratio r. So this base, the base of the power, that r value, is ratio. Okay, it's a ratio. And so that ratio tells us stuff. If r is, the absolute value of it, is greater than 0 but less than 1, then the geometric series is going to converge. If the absolute value is greater than or equal to 1, then this series is going to diverge. The reason for that is because the r, so if I come back up to here, the r value, if it's, say, 1.5, and I raise it to any power, this number here is actually going to get really large, right? 1.5 to the infinity is going to be really, really large. But 0.5 to the infinity is going to be really, really small. So it's going to converge to a certain value because it's less than 1, right? Any number less than 1 but greater than 0, when I put it to a power, it's going to become a smaller value. Okay, so we got to think about that, and that's the reason why I'm able to do this. Alright, so let's do some testing of this geometric series. First one here. I want to make sure it's in the form of AR to the N. Okay, that's what I want to do. So because this is already, like A is 1, right? R is 3 over 2, and N is that power. 3 over 2, okay, the absolute value of it is definitely greater than 1. And because it's greater than 1, well, R is equal to that, then this series, I can't spell, series diverges, right? Based on the geometric series and the R ratio test. Okay, so the series converges. Oh, I'm sorry, diverges. Oof. This one here. Well, this is, I can rewrite this as 3 times 1/2 to the n power. It's the same thing. It looks a little different, but it's the same thing. And because the r, okay, the r is equal to 1/2, so if I take the absolute value of that, which is less than 1, okay, and it's greater than 0, obviously you can see that. And so this series is going to converge. This is going to converge based on the geometric test. So because of the geometric test, and I should have probably wrote that there as well. This one here, this one's going to look a little different, but remember from last section when I can break up series. So this series is the same as n equals 0 to infinity of, because my fraction, I have a binomial on top and a monomial in the bottom, I can split the fraction. So this is 2 over 5 to the n minus that same summation of now what's left. So I get 3 to the n over 5 to the n. So this one is going to be 2 times 1/5 to the n, and this one is going to be 3/5 to the n. Okay? So, because r in this case is 1/5, right, which the absolute value is definitely less than 1, okay, and then this r is 3/5, but the absolute value of that is definitely less than 1, because both series, the ones that I split them to, like this one and this one, converge. Because both series converge, the original series converges. So I split this one series, a single series up in the beginning, the original one, into 2 different series to find the values of each of them. I manipulated it to find the r value in the first one, the r value in the second one. Because both of those converge, they're less than 1, the r value, then the original sequence, the original series up here is going to converge as well. If one of those converged but the other one diverged, then the original function is not going to converge necessarily, so you have to do some more tests when we get that far. Okay, let's go on to number 4. Number 4. Let's look at it. Okay, so this is the same as n equals 0 to infinity of pi over e to the n. Pi over e to the n. Okay, well, what is pi? Well, pi is about 3.14, and e is about 2.71, somewhere around there. That is definitely greater than 1. So r is equal to pi over e, but the absolute value is greater than 1. Thus, the series diverges because of the geometric test. Geometric test. Okay? Cool beans. Last one, or not last one, but this number 5, I guess. Because r is equal to 1 plus k over n, so k is just some value, okay, some value. So this is our r value, and the absolute value of this, okay, we don't actually know what's going to happen to this, right? So k is some constant. We don't know what the value of k is, so we got to think about what could happen if k is greater than 0 or less than 0. So if k is greater than 0, so 1, 2, 3, 4, 5, and whatever, then what's going to happen? Well, then this is going to be some value plus 1, so this is going to be bigger then r is going to be bigger than 1 when k is greater than 0, and thus the series is going to diverge. Series diverges. If k is less than 0, meaning k is now negative, and n is positive, and this is going to go up and up and up, and k, could be -1, doesn't really matter, but 1 plus -1 over whatever is going to be smaller than 1. So therefore, r is going to be less than 1, okay, and therefore the series converges. So again, we got to understand and think about what it's actually meaning. So the series will converge if k is less than 0 and diverge if k is greater than 0. The geometric series is one of the few series where we can actually find the sum instead of just saying it converges or diverges. So the sum of the geometric series, this is something you got to know, this actually, right, a times r to the n, is given by s equals a over 1 minus r, provided it converges. So if the series converges, we can find out the value that it converges to. Okay, we can find the value. If the series diverges, then obviously we don't need to do this, and don't worry about it. Notice that this summation starts at 0. So this is going to start at 0. Starting values other than 0 will impact how we evaluate them. So we're going to have one of those examples where it doesn't start at 0, or actually 2 of them actually, and we'll get to those, but let's first start at 0 on the first 2. So these are pretty easy. Okay, it's not that bad. So in this case, right, this is 3 times 1/2 to the n, and therefore r is equal to 1/2, which is less than 0, so this converges. So great, it converges. We actually did this one in the previous page, right? And so because this converges, we know that a is equal to 3, right? That 3 is our a value. So now I use this. So the sum is equal to a over 1 minus r, which is 1/2, right? So this is equal to 3 over 1/2. 1 minus 1/2 is 1/2, which is equal to 6. So the series converges to 6. That's what that number means. Okay, fantastic. Let's look at this one. So we split this up, right? We split this up into 2 times 1/5 to the n, from n equals 0 to infinity, minus the same sum from n equals 0 to infinity of 3/5 to the n. We know that these both converge, right? So this converges because r is less than 1. We figured that out up in the previous example. And so because they converge, I can now find the value of them. So if I take this and evaluate this, and then I subtract off the value of this, I'm going to find out what the full series is going to converge to. So a is 2 here, a is 1. R is 1/5 here, and r is 3/5 here. So I get 2 over 1 minus a fifth, which is, I'm going to then subtract that from 1 over 1 minus 3/5, okay? Which that's equal to 2 over 4/5 minus 1 over 2/5, which is then going to be equal to 0. If I actually do the math, I'm going to get 0, which is kind of crazy, but this is actually 10/4 minus, and this is 5/2. So common denominators would give me 10/4, so I get 0. So this series is going to converge to 0. That stinks. You did all that work and didn't converge to a number other than 0. Oof, that stinks. Okay, let's do some ones where n is not 0. N is now 1 and n is 2. All right, let's figure it out. So first here, okay, we got to make sure it converges first. Whether, I don't care what n is equal to. I don't care about this yet. We can determine if it converges or not. Okay, so let's look at it. We know r is negative a third. Okay, r is negative a third, so the absolute value obviously is less than 1. Okay, so and then a is also 1, right? The 1 in front of there is a. So because it converges, we know that we got to find the values of from n to n equals 0. Okay, how do we do that? Well, here's how we do this. Because it's going to converge to a over 1 minus r, right? Because it converges, this is less than 1. I can find this value. So that value is 1 over 1 plus a third, which is equal to 1 over 4/3, which is equal to 3/4. So this series is going to converge to 3/4. Okay? Based on n being 1. Based on n being 1. How do I find what the first term was? So what I have to do is I have to find a sub 0. A sub 0. Well, if I plug in 0 into this, I'm going to get positive 1. So what I then got to do, okay, I got to take the 3/4 that function is actually converging to. I have to subtract the 1 from the a sub 0, the first actual term of it, and I'm going to get negative a fourth. And therefore, the actual series here, n from 0 to infinity, okay, well, I guess I'll change this to 1, of negative 1/3 to the n converges to negative a fourth. Right, negative a fourth. So you have to, when you do not have n is equal to 0, you have to find the a over 1 minus r like you normally would, what it converges to, and then you have to take that number, subtract it from the a sub 0 term, and then you get your actual converging value. All right. This was a little more tricky because now we have 2 values to actually find out. Okay. So let's do this one. Well, does this converge? Well, this is negative 3 times 1 over 4 to the n. So r is equal to a fourth, which the absolute value is less than 1, so this converges. So that's cool. Okay, let's find out the value. So we know a is negative 3, r is 1/4. Let's find the thing that it converges to, the value it converges to. Negative 3 over 1 minus a fourth, which is equal to negative 3 over 3/4, which is equal to negative 4. So this series is going to converge to negative 4. But it's not, it doesn't start at n equals 0. So because it doesn't start at n equals 0, I have to find a sub 0 and a sub 1. Well, if I find a sub 0, which I plug in 0, I get negative 3. Okay? If I plug in 1, I get negative 3/4. All right? So now I have to take, again, what the series here is converging to, subtract off all of the other pieces. Negative 3 minus negative 3/4. Minus a negative, that's actually, I'm sorry, it's plus a negative 3/4. Okay, I got to add these up. I got to add these pieces up. So it's really plus a negative 3/4, but it really becomes a minus 3/4, right? So it's the same thing. Okay, I got to find out what that is. So it's negative 4 minus, And then really I can distribute, I guess, if you wanted to. Distribute, so you get plus 3 plus 3/4, which is equal to -1 plus 3/4, which is equal to -1/4. So this series is also converging to -1/4. So you have to do the same step. So you find out first if it converges, then you do your a over 1 minus r. You find out what that converges to. Then you are subtracting off the addition of these two terms, -3 plus the -3/4. All right, and then you just calculate that and you get your actual convergence of the original series. All right, that's it for this video. On to the next one. Deuces.